Hi everyone, let's go over polynomial review, the language of mathematics. Algebra is a type of math where you use symbols to look at various relations. One such algebraic equation looks like this: 2 plus 2x equals 6. Coefficient is this value in front of x, the number in front of variable. And variable is this alphabet here. It's the unknown quantity. Each item in an algebraic expression is called a term. A term can be a single number or variable or variables and its coefficient. A fancy name for algebraic expression is polynomial. A polynomial expression with one term is called monomial. 2 terms is called binomial, and 3 terms is called trinomial. So let's take a look at some of the examples here. 2m is just one term. This is a coefficient and this is a variable. These are not separated by plus or minus operations, therefore it is just one term. So this would be called monomial. Second row here, 2x squared plus 1. I see one term and the second term separated by an addition operation. So that would be 2 terms and it's called a binomial. Alright, let's skip the third one and let's go to the fourth row here. So I see 1, 2, and 3 terms separated by addition and subtraction operation. 3 terms. So the polynomial type would be a trinomial. Let's go to the last example here. I see 1, 2, 3, and 4 terms separated by addition or subtraction operations. So if the polynomial have more than 3 terms, then in general they're called polynomial. Moving on, a degree of a term is a sum of the exponents on a variable. So for example, 3x squared would have a degree of 2, and 2xyz would have a degree of, there's a hidden ones here, and one here, another one. So there's a degree of 3. Moving on to the next page, let's take a look at this chart. We first want to find the degree of the term. So degree would be the sum of the exponents. So we have 4. Second example, I see 2 here, and I know there's a hidden 1 for x. So 1 plus 2 equals 3. So degree of a term is 3. Third example, 1 actually has a hidden variable with the exponent of 0 on the side. So this would equal to 1. So the value itself doesn't change, but consider it like the zero exponent, which means the degree of a term of a number is 0. Last example, 5mxy. There's m to the 1, x to the 1, and y to the 1. So when we add up the exponents, then we get 3. If we are asked to find the degree of a polynomial, we only need to state the degree of the term with the highest value. For example, if I have an expression 2x to the power of 4 plus 2x y to the power of 2 plus 1, then we first need to check the degree of each term first. So we have this term, and second term, and then third term. The degree of the first term would be 4. Degree of the second term would be 1 plus 2, which is 3. Degree of the third term is 0, because that's just a number. And we can state that degree of polynomial is 4. Let's take a look at like terms. When terms in a polynomial have the same variable with the same exponents, we say they are like terms. For example, 2x and 5x are like terms, as are 2x squared and negative x squared. You can add or subtract like terms by adding, subtracting the coefficient. And again, coefficients are the numbers in front of the variable. Let's take a look at the chart here. Alright, so from the first example, we could see that s squared is both present in the first and the last term. So the like terms are 3s squared and 2s squared. Combined equation would be 3s squared plus 2s squared plus 2. I'm going to write that down for a second. This plus 2s squared plus 2. And the instruction previously said you can add or subtract like terms by adding and subtracting the coefficient. So we're going to add these two coefficients. So we have 5. The rest follows. Let's try the next example. There are 3 terms, and the only like term I can find would be 1 and 4. 1 and 4. So this time we're going to combine these two. So 1 plus 4 is 5. And then the rest of the expression follows, minus x squared. One more example before we go. Let's take a look at the third example. We have 4 terms. I see p to the power of 4 in the first term and p to the power of 4 in the third term. Also, I see the -5 and -2. Those two are the like terms as well. I like to put this into a list, say 2p to the power of 4 and p to the power of 4 are like terms, and -5 and -2 are like terms. If we were to find the combined equations, we can just add the coefficient in front of the variables or the constants itself. So we have 3p to the power of 4 minus 7. Please work on the rest of the examples here, and we'll go over it together.